Geometry problems and quadratic equations. So just a quick recap for our strategy with problem solvings. We read, identify the variable in the problem, translate this problem into an equation somehow, solve the equation, and then check that our solutions are possible, and then we'll finally give an answer. Now in geometry problems, we're going to have to find geometric equations that will help us solve these problems. So let's start by reading the problem first. An architect is designing an entryway to a restaurant. She wants to put a triangular window above the doorway. That's going to be important, I think, because I see a shape in there. But due to energy restrictions, it can only have an area of 120 square feet. I'm going to underline that as well. Area of 120 square feet is going to be important. The design requires the window to have a base of 4 feet, so a base of a triangle of 4 feet more than twice the height. So here we have a number problem sort of put within this geometry problem. And then we need to calculate the base and height of the window. So before I get to the variables just yet, I'm going to draw this problem. So it's a triangular window. And what I know is I've had the height and the base described to me. And I know that the area is going to be 120 square feet. So that's a little picture of what the problem looks like. But now I have to use the fact that the base is 4 times more than twice the height. So because the base has this complicated relationship to the height, what I'm going to do is use the height as x, because it's going to make writing the base as a bunch of things times or added to this much easier to write. If I made the base equal to x, then it would be very complicated to write the height. But I will make the height equal to x, so the height is going to be x, and then the base, oops, I just deleted my height. So height is equal to x, and then the base is going to be related to that. So the base is 4 feet more, so whatever this is plus 4, than twice the height. So 2 times the height. The base is 4 feet more than 2 times the height. So the base is 2x plus 4. Now I can go ahead and set up an equation, and the equation I'm going to choose has to have something to do with this area, because if I don't use the area, then I don't have any number to help me actually solve the problem. So I'm going to use the fact that the area of a triangle is the base times the height divided by 2, because that means I know the left-hand side is 120, and then the base times the height would be 2x plus 4 times the height, which is x, all of which is divided by 2. And I like the looks of this equation because it has only one variable, which is x, and I should be able to solve it. I'm going to give myself a little more room here. So I'm solving the equation 120 equals 2x plus 4 times x divided by 2. So in order to solve this, I have to make it look like a quadratic equation. So I'll multiply each side by 2. Then I have 240 equals 2x plus 4 times x. And so I'll multiply that x in. So that would be 2x squared plus 4x. And now let's subtract this 240 here in that same step. And I have a quadratic equation now. Can I factor this equation to solve it? Let's see. Before I do that, there's a greatest common factor here. So I'll factor off the 2 from each term. That's going to make my life a lot easier. Now this is a simple trinomial, so I need a couple of numbers that multiply to negative 120 and add to 2. So I just did a little bit of searching on some scrap paper and found that 10 and 12 should work for me, because if I do positive 12, negative 10, I get plus, they add to plus 2. So this would look like 0 equals 2 times x minus 10 or x plus 12. So either, if all of these things multiplied together is equal to 0, then either x minus 10 equals 0, so x equals 10, or x plus 12 equals 0, so x equals negative 12. Now remember that these have a very specific meaning. X here is the height of a triangle. So having a negative measurement of a height makes no sense. So we have to actually reject one of our two solutions. I always would like you to have a rationale whenever you reject a solution. Don't just say reject. Give her a little reason why. So can't have negative height. So we reject one of the solutions, which means we now have potentially only one valid solution. So if x was equal to 10, so that would mean that the height is equal to 10, then the base would be twice that height plus 4, which would be 24. And as a quick check, if I have a triangle with a base of 24 times a height of 10 divided by 2, that should give me an area of 120, and it does. So I'm happy with that solution of x equals 10. So now we can answer this as a sentence. The height, so we're calculating the base and height. That's what they ask us for in the problem. So we should say that the height is 10. And what are the units? Well, if they multiply to an area of 120 square feet, then each unit must be measured in feet. So the height is 10 feet, and the base is 24 feet. In the second example, the width of a tablet is 7 centimeters less than the length, and the surface area of the tablet is 690 square centimeters. So I think we have to assume this is just a little tablet computer rather than like a stone tablet, but it doesn't really make a difference, does it? Because whether it's a digital device or a rock, width and length is still a rectangular object. So we have this rectangular object, and we know that the width is 7 centimeters less than the length. So the length is the simplest thing that we could make equal to our variable x. So if our length, so I'm going to draw a rectangle here, if our length is equal to x, the width is 7 centimeters less than that. So our length is equal to x, our width would be x subtract 7. And we know that the surface area is 690 square centimeters. So again, we are using an area to define this relationship. So we'll write area is equal to length times width, or in this case, 690 is equal to x times x minus 7. So that'd be 690 equals x squared minus 7x. So we're subtracting 690 from each side. And now we go ahead and start the solving process. It's possible that this has a decimal solution that we can only find with the quadratic formula. But before I resort to using the quadratic formula, I'm just going to try to find a few factors of 690 in my calculator. So I'm just going to divide it by some different options. And I got super lucky. I said 690 is probably divisible by 30. So I just tried dividing 690 by 30, and sure enough, another factor is 23, or it's divisible by 30, and I get 23. And if I was to use negative 30 and positive 23, they'd multiply to negative 690, they'd add to negative 7. And so this was factorable, and I got lucky with my guess, but it was an educated guess, so I'll take it. So this implies that x is either 30, and the units would be centimeters, or x is equal to negative 23 centimeters. So again, we're going to reject a negative solution because it just doesn't make any sense physically. Can't have a negative 23 centimeter side. So that leaves us with the length is 30 centimeters. So when we want to know the dimensions of the tablet, that means length and width, the measurements of the sides. So the length is 30 centimeters, and the width is 7 less than 30. So 30 minus 7 is 23 centimeters.